Okay, in this video, we're going to do a problem that we did in class on Monday, the February 23rd, that involved zero-dimensional defects. We classify defects into zero-dimensional, one-dimensional, two-dimensional, three-dimensional, and within zero-dimensional defects for a crystal, we talked about impurities and interstitials and vacancies. This problem involves interstitials and some impurities. So we're going to start with a silicon crystal that has some phosphorus added to it, but added to it in such a way as that the phosphorus is replacing the silicon. And so 0.1% of the lattice have been replaced. And we're also going to add some sodium, but the sodium for this problem we're adding as an interstitial, not taking up a lattice position. So we're going to add 3 times 10 to the 18th sodium atoms for every cubic centimeter. Okay, and the original density of pure silicon we'll say is 2.33. And for the sake, just for this problem, we'll say it's 2.33000000. It isn't, but let's just say it were. Okay, so we're going to start by picking a volume. So we're going to just say, to do this problem, we're going to choose a volume of 1 cubic centimeter. So this is a way of thinking about these types of problems. So pick a volume. And once I've picked that volume, I can get the mass of all the atoms inside of it before we add any impurities and before we add the sodium. I'll get the mass, which is density times volume, which gives us 2.33 grams if it was pure silicon. Then, since we know the weight of it, or the mass of it, we can figure out how many silicon atoms were in that sample. And you've all done problems like that from week 1, so we figure out that it's about 5 times 10 to the 22nd atoms. Okay, now, for the actual crystal, some of those have been replaced. So we still have 99.9%, and that's where this 0.99 comes from. So we still have 99.9% of those atoms. We replace the missing ones with 0.1% phosphorus. So we take the number of atoms, the 4.98, multiply it by 0.1%, and that's how many phosphorus atoms we have. So the new density is going to be the mass of the silicon atoms, which is not the same as it was before because I have only 99.9% of them, plus the mass of the phosphorus atoms, plus the extra sodium atoms that we add. Now for the sodium atoms, we're going to take the 3 times 10 to the 18th and multiply it by the volume, which in our case is 1 cubic centimeter, so the number of atoms is also 3 times 10 to the 18th. So to get the weight of those sodium atoms, I need to take that and multiply it by the mass of one of them. And FYI, to get the mass of the phosphorus atoms, I would take the number of phosphorus atoms and multiply it by the weight of one phosphorus atom. And when I do all that, I get this is the mass of the silicon, this is the mass of the phosphorus, that's the mass of the sodium. And my new density is all that mass divided by the same volume, because we didn't change the volume of this crystal, and I get 2.33098